So let's get a going. So after we did the adding and subtracting of algebraic expressions in our last lesson, we're now going to have a look at our applications. So just to remind you about what we were doing, all right, let us share the pictures that we had. All right. So that's not your stuff. That's your stuff. All right. So remember with algebraic expressions, they are pretty much related around variables, which represent an unknown number. The number in front is your coefficient. If there's no variable, it's known as a constant. And importantly, this is an expression because we do not have a left-hand side and a right-hand side. So when we dealt with adding and subtracting, it was very interesting about all the stuff and all the misconceptions that came out, that you had to make sure that you had the same variables, not just the same letter in the same form. So if you didn't have that, then you couldn't simplify. So here, a lowercase t and an uppercase t are different variables. Similarly, even if you have the same variable, but the exponents are different, they're different, and you cannot simplify them. So here, we had different exponents on sum, the same exponents on sum, just a different order, and that we found out that we could add because in multiplication, you can change the order around, and therefore x squared y like that and yx squared like that are actually the same thing. Because x squared y here and x squared y there, you can add them together to get your 7. All right. So that is what we had to look at last time. Now, this time, we're going to be having a look at perimeter. So the question is, what is perimeter of a 2D shape? Because it's important also to remember that perimeter does not exist actually in 3D shapes. So perimeter of a 2D shape is the outside edge length. So if you have a rectangle, for example, it is this side plus this side plus this side plus this side. If you have a 3D shape, you can calculate edges or length of the edges, but it's not really considered as anything direly useful, only if you look at a face of your 3D shape, being one side of it, and then focus on that, does it then become something? But if you do that, you're only working then with the 2D shape, and it then essentially becomes perimeter anyway. All right. Now, if I give you a shape like this, I say to you, this side is 12, that side is 4, and this is a rectangle. And I say to you, calculate my perimeter. Hopefully this doesn't stress any of you guys out. So what do you believe the perimeter to be? Let's quickly type it into the chat. All right, so most people are coming out with an answer of 32. And most likely the way you got 32 was because you took 12 and 4, and then you realized this was also 12 because it's a rectangle. This is also 4 because it's a rectangle. and you add them all together. You get 12 plus 4, which is 16, plus 12 and another 4, which is another 16, gives me 32, and I'm very happy. Great. Now, you can also get perimeter of different shapes, maybe some more complicated shapes. So what about if I maybe have a shape like this? So this is not a normal, this is a rectangle, this is a square, this is a triangle sort of shape. I give you that side is 7, that is 5, that is 2, that is 1, that is 3, that is 10. And I tell you, find my perimeter. So tell me what the perimeter is. All right, so I see there is a raised hand. I'm just going to go through first, and then I'm going to come to you. Or hand lowered. Okay, cool. All right, so let's see the answers. So we have got some people. Let me just change color again. All right, some people saying we've got a 28, we've got a 27, we've got a 29, 35, 29, 35, 36. Okay, cool. So let's have a look. If you take all of these numbers and you add them together, you get 10 plus 7 is 17, plus 5, which is 22, plus 2, which is 24, plus 1, which is 25, plus 3, which is 28, which gives this answer, which is great, except you'd be completely wrong. And why would you be completely wrong? Because you have not added the outside edge. Now you might be saying, but I've added all these numbers, they are on the outside, there's nothing wrong. Well, the outside edge is not just the numbers you are given, it is everything. It is all edges. You do not know how long that edge is. You do not know how long that edge is. And that is the problem. So we now need to calculate what these edges are. How do we do that? Well, we know that this shape has parallel sides, meaning that if this whole side here is 10, this side plus this side plus this side must also give me 10 because they are the same widths. So therefore, this is 5, that is 8. The total is 10. This side must be 2. Fantastic news. What about this unknown side? Well, I know that this whole side here must be 7, which is that plus that plus that. That's 2, that's 1. Together gives me 3. The whole thing is 7, means that the other side must be 4. Now that I have all of my sides, I need to actually add them now all together. Well, since I know that all the given sides were 28, I can therefore just add the 2 and the 4, which are new, and 28 plus 2 plus 4 gives me 34. All right, so this is very important because there will be questions like this, and there will be missing sides, and you will have to know what to do about it. But this was also quite a nice question because it's just numbers. And they're not going to be that nice to you. They're going to introduce variables into this type of scenario. So, what about if I introduce the following over here? So let me erase and I am going to get rid of that. I'm going to get rid of that, not that, that, that. All right. So this is the same example, but what I'm going to do now is I'm going to just put in a little bit of a variable spin on this. So this is now x, and this is now y. How are we going to calculate our missing sides? So we're going to calculate them in exactly the same way. We know that this whole thing is x, and that must be this side plus my unknown plus this side. So 3 over here plus the 5 over there gives me 8. 8 plus what gives me x? Oh, I don't know. Suddenly people start flipping out. Well, what did you do before? When this over here was a 10, you took the 10, you minus the 5, you minus the 3, and you got a 2. Now that this is an x, what are you going to do? Exactly the same thing. So we have x, we're going to minus the 3, we're going to minus the 5, and together that gives me x minus 8. Can I simplify this anymore? No. Please make sure you do not start cancelling part of the x or anything ridiculous like that. Yes, I know that has a curve there. I know that has the curve there. It does not mean you can start cancelling stuff. I mean, if you've got an x there and an x there and you want to try and cancel that with this bit, and then it will, and that with this bit, and then it will just leave you with that. Does that sound like right maths? I'm really hoping you're saying no, because no. So this side is then x minus 8. What about my vertical lines? Well, this side must equal this side plus this side plus this side. And what did we do last time? This was 7. 7 minus 2 is 5, minus 1 gave me 4. Now there's a y, you flip out, you go, I don't know how to work with variables. Well, it's exactly the same thing. It's y minus the 2 minus the 1, and that gives me y minus 3. And I cannot simplify this anymore. And now that I know all of them, if I want to calculate my perimeter, I have to add all my sides together. So starting at the top, going anti-clockwise round, it is x plus y, so x plus y plus 5 plus 2 plus x minus 8 plus 1 plus 3 plus y minus 3. And now we collect our like terms, just as we've always done. So x plus x gives me 2x y plus y gives me 2y. And so that I know I've counted it, I'm going to cross them out. And then I do my numbers. I've got 5 plus 2 is 7. 7 plus 1 is 8. 8 minus 8 is 0. 0 plus 3 is 3. Minus 3 gives me 0, which means that that is my perimeter. Isn't that interesting? Now, I'm hoping that you're looking at this and saying, sure, that's really cool. We found that out. That's very interesting. And then your eyes draw down a little bit and you have a look at this and you're like, that almost looks familiar. That almost kind of looks like that when I take out my common factor. Well, that's even more interesting because this is actually the formula that you're given in your textbooks for calculating the perimeter of a rectangle. Which means you could have taken x plus y and doubled it. Well, of course you should have, because this side could go there, this side could go there, that side could go there, and that side could go there. And then you just create a normal rectangle. So that's why it has to come out as this answer. Now that was magic. But what about if I give you another shape? Here's a triangle. One side is x, one side x plus 7, one side x plus 5. And I say to you, calculate my perimeter. Got a couple of answers coming through. You've got a 15. You've got a 12. You've got a 12x to the power of 3. You've got a add command or file name. All right, well, some of you have figured out my mathematical powers and are getting it right. The correct answer is indeed 3x plus 12. How did we do that? Well, what is perimeter? Perimeter is the sum of the lengths of the outside edge. So we add all the three together. X plus 7 plus x plus 5. So x plus x is 2x, not x squared. Plus x is 3x. And then 7 plus 5 gives me 12. Just that simple. All right. So taking from this one over here, If you take the 3x and you add to 12 and you get 15, that's a problem because you are adding unlike terms. Yes, the 3 is a number, the 12 is a number, but the 3 is a coefficient of the x. This whole thing is a term that you can't just split and deal with individually.